Hi, welcome to my channel. Today I'm going to be deriving the arc length of a circle. Okay, let's take a look at what I've drawn here. I have a circle of radius r and center point C. I have a couple of rays that extend from center point C to points A and B that lie on the circle. Now, the angle between the rays is what I'm labeling as theta sub d. The sub d just indicates that the angle is in degrees. This angle is often referred to as the center angle. That's because the vertex of the angle lies at the center. It can also be referred to as angular displacement or angular distance. They all mean the same thing. It just depends upon your text. Now, this portion of the circle here between A and B, I'm going to go ahead and just draw it like this. This portion of the circle here between A and B is called an arc. This one specifically is called an arc AB. And the distance between A and B, the distance along the circle on this arc between A and B is known as the arc length. And that's actually what we're trying to solve for here today. So we want a mathematical equation that describes the relationship between all the parameters that we've discussed so far, such that we can solve for arc length L. So essentially we're looking for something in the form L equals bunch of stuff. You know, letters, variables, maybe there's a pi involved. Well, of course there's a pi involved, it's a circle. Okay, I went ahead and wrote down what theta sub d and L were. Once again, theta sub d is the central angle, or angular displacement, or angular distance, and L is the arc length, or more specifically, the length of arc AB. Anytime I work any type of problem, I like to write down what I know. What does the problem give me? What can I logically infer? These are two questions that I ask myself whenever I work any type of problem. Well, I'm dealing with a circle, and it's a circular path, and there's two things that I should know immediately when dealing with circles. One is the total angle, and the other is the total length. Well, the total angle, the number of degrees in one cycle, in one revolution of a circle, it's 360 degrees. And the total length is just the circumference, and we know the circumference formula is 2 pi times the radius. I'm calling the total angle theta total, and that's 360 degrees, and I'm calling C the total length, which is just the circumference, which is 2 pi times r. Okay, so let's take a look at what we have. We have angles and lengths. Theta sub d and L are partial angles and partial lengths, whereas theta total and circumference are total angles and total lengths. Well, the beauty of this is that the ratio of the part to the whole is the same for length as it is the angle. They're proportionate. So that means that the ratio of the arc length to circumference equals the ratio of the central angle to 360 degrees. Okay, let's convert that sentence into math, more specifically an algebraic equation. Okay, I'm going to scroll down a little bit to give myself a little bit of room, and I'm going to go ahead and convert this to math. So I'm going to go ahead and start the fraction bars. I'm going to make that white. And what we have here is we have arc length divided by the circumference equals, you have the central angle, theta sub d, divided by the total angle. And there you go. That's the relationship. That's the equation for the sentence above. So that's not exactly in the format that we want, although that captures what that sentence is saying. That captures our relationship. What we want is, we want the L by itself. So in order to get the L by itself, we'll have to do just a little bit of algebra, which is not too hard. And we want to get rid of this 2 pi r in the denominator, so we're going to multiply by 2 pi r in the numerator there. And if you multiply by 2 pi r on the left, you have to multiply by 2 pi r on the right to maintain that equality. And so that's going to cancel out with that. And what you're left with is, oh, let me get my color back. Okay, arc length, oops, I should have done this. Okay, so arc length is going to equal the central angle divided by the total angle multiplied by 2 pi r. And there you go. That's our equation. That's what we've been trying to work toward. And I hope at this point that this makes intuitive sense. So what this is saying essentially is just that, hey, the arc length is equal to the circumference multiplied by this subset, by this small portion, right? And that should hopefully make intuitive sense because the arc length is the circumference multiplied by the fraction of the total angle that the central angle occupies. So if we look back here at our picture, so the total circumference, so we just want this component of the total circumference. So if we take the total circumference and multiply by this ratio, the ratio of the central angle to the total angle, well, that'll give us that portion of the circumference that we're interested in, also known as our arc length. So that wasn't too bad. So actually, you know, we could simplify this a little bit further. We can divide by 2, and I'm going to go ahead and do, you know, let me go ahead and do this in white. I'm just going to go ahead and do this in white. It'll be a little quicker. So I can simplify that. So what I'm going to have is I'm going to have L equals theta sub d over 180 multiplied by pi r. You know, another thing that we can do, another way that we can rearrange this rather, is we can actually solve this for theta sub d. If we solve this for theta sub d, just going to go ahead and do it. So essentially this is multiply both sides by the reciprocal here. So multiply both sides by 180 divided by pi over r. So you have L divided by pi over r times 180. And that is that's how you calculate the angular displacement. And this is how you calculate for the arc length. And there you go. That's it. Okay, well, cool. Well, that's it for my first video. My first video is in the books. I hope you found it helpful. If you did, please leave a like and subscribe for more content. If you have some issues with how I explain something, please leave questions or suggestions in the comments. Constructive criticism is always appreciated. After all, I am learning too. Okay, well, have a wonderful week, and I'll be back very soon with something else.